Thank you so much for the kind introduction, Duff, and thanks to everyone for showing up. Sorry, I ran into a bit of traffic coming here, so that's why I was just a tiny bit delayed, but just in time for this introduction that I'm going to give you about AI using documents, both from a little bit of technical and not really technical, more of a technical low-code perspective, and then a bit of the regulatory adventures. Because I'm actually a trained legal scholar, but I work a lot with AI researchers such as machine learners, people from the fairness community, mathematicians to improve on AI and make AI better, safer, and more compliant. I'm also quite active in the policy space. I advise the German federal government in various roles on the European Commission, the European Parliament, and as you know, there is also quite a bit going on in AI, including AI regulation in the U.S. We are not, despite President Trump's efforts to tear all this down. But we have colleagues in the U.S. who do very various acts and efforts in the U.S. We know that at state level, for example, in the U.S., for example, in California right now, there's a new bill precisely about transparency and some of the stuff, the labeling stuff that we're going to be talking about. I will not delve into the U.S. landscape too much. If you have any questions about it, I'm going to be answering them afterwards to the extent that I can. Also, any questions that might come up concerning, some of the stuff that I'm presenting, feel free to just raise your hands while I'm talking, or also afterwards if you'd like to. So, let's see what we're going to cover. I just want to make sure that we are on the same page when it comes to AI. So I suppose you all have some technical background, and I don't need to explain everything here, and I can't because it would take me 3 weeks to conceptualize that, even though we wouldn't be finished because you ask 3 machine learners what is AI, you have 4 different opinions, of course, but we're at least going to talk just a little bit about what it means. And I see, look at 2 cases of how AI can or cannot improve document workflows before asking ourselves the question, what's kind of the trade-off between efficiency and risk in introducing AI in some of these landscapes. And then I want to put you on notice of some of the recent developments that we've seen here in the EU concerning AI and the AI Act, which is something you might have heard about. And the interesting thing is that this applies to AI no matter where it is produced, no matter where it is trained, as long as the AI model or system is then also used in the EU. So to the extent that you want to tap into the EU market, it's a pretty big market, you need to make sure that you're somewhat compliant with the AI Act. And I'll show you that actually it's not too difficult if you follow some main guidelines, some compliance strategies at the end. Okay, great. So let's get started. And I'm just going to say that, of course, I can only scratch the surface on a number of things here today. So if you'd like to, I have a lot of papers up on the internet if you want to dig into some of this stuff more deeply. Most of them are open access on archive. Okay, so AI, a loose concept. Let's start by asking, how many AI experts do we have in the room? 1. Okay, that's good. 2. Great. It's good for starters. What is AI, then? What's your definition of AI?
Making life easier.
Making life easier. Okay, but what I told on whiteboard, I'm sorry. Okay. So what's the other definition here? The other AI expert. Yeah. Shout it out.
Some kind of learning that is helping us to do tasks that we are not able to do, not automation. It does.
Okay, great. So it's not automation. It's not limited to automation. Yeah, that's something I try to stress all the times. While I actually told the European Parliament, I think about 5 times, and I still didn't get it. It's still wrong of the IX. You're right. And it's something that helps us with learning, or that is learning itself. So indeed, we can start out with the difference between cats and dogs, or between rule-based and AI systems. AI systems oftentimes means it's a learning system. So it's a system that has machine learning capabilities where usually a header loss function is optimized over a lot of data. So it's not, except for some expert systems that were developed in the 80s and then are now seeing some kind of comeback. it's not based on you tell the program exactly what it's supposed to look like, but rather it learns itself from examples. Why did I put that cat here? Does anybody know? Except for it being very cute, of course. No. So rule-based systems are notoriously bad in being able to distinguish, for example, a cat from a dog or from anything, and from just saying, this is a cat. Because if you try to describe a cat in a rule-based manner, it becomes pretty tricky, particularly if you want to differentiate it from other types of animal species. So the first time that you were actually able to really seriously hack images automatically was when machine learning was introduced. Because the machine learning model actually learns how to interpret on several dimensions these curves and edges and these funny ears or whatever, and is able in many instances to distinguish with a high degree of fidelity cats from dogs, which is something you can't do with rule-based. Despite the fact that what's really easy. Just eggs will be back. Our son just learned this. 8 months? Okay. So here, machine learning. What is machine learning? Means learning from examples. Okay. So many people during the drafting class of the AI Act, which was someone in call, many people said, "Hey, what is AI? You need to define AI because at the end of the day, if you do a law on AI, you better define what AI is. Otherwise, nobody needs to notice it applies or not." I kept saying, "Don't try to define AI. It's super difficult. At the end of the day, AI will be likely. Most experts would say it's something like a computer program that imitates the way humans think or act, or rational action or thinking looks like." And those are already a couple of differences in there, of course. But it's easier, actually, to define machine learning. Here we have a great example from Tom Mitchell on the Pioneers of the Field, 1997 already, page 2 of his famous book called Machine Learning. He says, what is machine learning? It's a computer program that is set to learn from experience E with respect to some class task T, performance measure P, if its performance at T measured by P improves with E. Okay, right? So basically, what that means is it gets better over time, right? The more it sees in terms of examples, the better it gets at what it's supposed to do. And that is what we call learning. That's what we call learning in children. You tell them, this is not a dog. No, this is not. This is a cat. And then after, 20 iterations, it knows it's a cat. This will take about 20,000 or more iterations. So it's not really intelligent yet very much. But at the end of the day, yes, it can do that. So next step, generating AI. And this is what's going to be interesting, of course, going forward as we go through our examples, because the distinguishing characteristic, first off, of generative AI is just that it outputs certain sequences that can be more or less weird. So sequences could be structures like words, then you get a text. Could be pixels, you get a news. Could be sequences of images, could be that's a video. Could be, tunes, then you get a sound. So basically, or it could be DNA bases, for example, for that matter. So which is why that's used a lot in biochemistry. So generative AI is not that different from traditional AI, but we will see in just a second that it has some crucial bottlenecks and limitations that are less present in traditional non-generative AI models. Today, actually, what is happening a lot of times, so when I, for example, work with industry, the people often tell me that they are not using just AI, because that would be oftentimes crazy, because AI does have error rates, of course, but they are using some hybrid models that contain both AI elements and rule-based elements. So they try to get to the best of both worlds. And this is something that's really intriguing to see, that despite the whole hype in AI, and maybe that's kind of clapping out a little bit, what people are doing in the field is actually trying to extract the best of value from the models, but then contain that, the errors, the hallucinations, with some kind of more rule-based structure that could be rule-based system, or it could be a more rule-based AI model, which is this symbolic AI. So neurosymbolic AI, for example, is a really interesting field of research at the moment. So how then does an LLM, a large language model, work? I don't want to go too deeply into this, but just a little bit for you to know and to see where kind of the pain spots are. So LLMs are all about tokens. What is a token? Does anyone know?
A piece of ore.
Sorry? A piece of the word. Exactly. Right. So a piece of a word or of any kind of sequence. So oftentimes you could imagine it to be a syllable. It is not exactly a syllable, but you could imagine it to be syllables. And LLMs just predict they try to predict the next token. This is something you might have heard about before. So how does that work? Well, you got to make it tractable for a mathematical engine, which is what AI at the end of the day always is. So basically, the big idea was to say, hey, we use these tokens, so we break up words into tokens, and we assign numbers to these tokens. And these numbers, they say something about the meaning of the word, and other numbers say something about the position, whether it's at the beginning or the end of a sentence or something like this. And these numbers, they're learned over time, and the basic idea is to get a similar meaning for two words or two tokens, then you have a similar number, which is then a similar vector. So for example, you could have here the sentence, the dog is not ready. Okay, and this gets split up. Let's make it really easy. It's a two-dimensional vector space. Of course, it's multi-dimensional. But we could say, hey, here's the, is, red, dog, etc. So what happens now if we introduce other types of dogs, or some types of dogs, the German Shepherd, of course, the famous Corgi, those would be kind of close to where the word dog is. So let's say we have these vectors here. Let's say dog is whatever. It's 0, it's 5, 0 or something. And then this would be 5, 1 and 5 minus 1 or something. So the interesting thing is that even though the model in the training data perhaps has never seen anything about German Shepherds or Corgi, it might be able to say something that looks plausible about them because it knows that it's close to dogs and it will likely behave like a dog in the linguistic sense. So that's the idea of how, even with some incomplete training data, you can generate somewhat meaningful sentences. But what you need is the attention mechanism. This is, of course, people. Yeah. What would it for red setter? Sorry?
In that context. Red what? A red setter.
Which is a different kind of
dog bits, right?
Yeah. Yeah, it might be a little bit up here. So, and then others cluster around here, but you have a lot of dog races. So that's why that used to be very multidimensional. I'm not a dog expert myself. So you would have to tell me where exactly it sits between the German Shepherd and the Corgi. Most likely somewhere in between, right? Or up or down or somewhere. Yeah. Or toward the red. Oh, you mean the red? You understand the red? Ah, okay, because of the red. No, that's the red herring. Okay, that's a mistake. Yeah, that can be really confusing to an LLM, actually, because it contains this other word that is supposed to denote something else. Which is why then, now we look at the attention mechanism. The cool thing about the attention mechanism, here comes the answer, basically. The attention mechanism is something that was invented in a paper by 7 or 8 Google scientists in 2017. Paper is called Attention is All You Need. And it basically means that you are able to analyze these different tokens, like red, in a context. So you would not only look at it step by step by step, which creates problems, for example, when you talk about things in a metaphorical way, and you still know this from the good old Google Translate days 10 years ago, when everything was kind of translated in a totally literal sense, one word after another, which, of course, in many cases created total nonsense. Here, it actually looks at the whole sentence, and then it would hopefully recognize that in this case, it's a red setter where those two belong together and form one dog species rather than red and then some whatever other type of word. So that's the basic idea that really kicked off a whole new dimension in translation, for example, when Google changed from the old model to a model that was able to understand some of the context. So for example, this is why nowadays you can say or input as a prompt, as I did here in this is GPT. This was still GPT-4, I think. I went to the yellow bank and put my feet in the sand by the river, so it understood that I'm talking about a river bank. Well, I went to the yellow bank and withdrew some money. It understood, and I said generate an image. It understood that I was talking about a bank where you can get money. Sometimes also you get funny mix-ups that also happen. But they're getting less and less, so these models are getting better. And output is then simply kind of a probability distribution that's calculated over the possible next tokens. So it could be, 10 of this can go one end to another, and then you mix them up a little bit. You ingest normally some randomness because that actually improves the flow of a sentence, but it also means that you're just predicting the next token. You don't really know what's going to come out of it. Actually, it was a really interesting paper that just came out from Yoram Muradki. I don't know if you've seen it. What's it called? Defeating Non-Determinism in LLMs. Basically, they showed that there's different sources of randomness in LLMs, and Yoram Muradki is the former chief technology officer of OpenAI, who then went on found their own company. And they're working on making LLMs more precise and more deterministic, which is something that current LLM structures do not have. And randomness, including randomness that is there for a reason in order to make sentences sound better and make flow of language better, they also generate, of course, some of these problems that we have with hallucination. So that's just what I want to say about, the structure of LLMs, not to enable you to build your own ones, but rather to create some awareness around the fact that randomness is a feature, not a bug in many of them. But at the same time, of course, it creates these problems that we have with reliability and reconstruction. All right, I know we heard about agents all the time, so I just want to put this out there. It's apparently the age of agents now. We'll see if that really comes up to, really gets us up to speed. It's true that if you can deploy agents at scale, for example, in a company that can help with a number of issues. So agents basically just mean you have some kind of AI model that's often specialized on a specific task and that is able to be integrated and use external tools, such as calculators or forms or reserve your next flight. I'm still waiting for one that, does all my flight expense calculation, all this stuff. So that'd be great and automatically feeds it to the university department for reimbursement. So that will be something very useful. I think some of the companies that you are working with might be actually in a better position to help it than our university. But the idea is it's not magic. It's just an AI system that's tuned up with external tools, which means it can do a lot of things that otherwise wouldn't be able to do. Can also create a lot of damage, of course, because if it reserves the wrong flight or orders the wrong food or whatever for you, that's, of course, a different kind of thing than just a recommendation that you get out of ChatGPT or Claude or wherever the freaking GPT. Okay, so that's just a very short intro into the AI model space. Any questions about that? You have, of course, seen, I guess, a number of applications of AI in the document workflow space. And basically the idea, I think generally, is about automating some kind of processes such as drafting, data extraction, or analysis that otherwise would require more manual labor. And I think the big value is particularly from unstructured data, because LLMs and LLMs in particular, but also other types of AI, they are able to get structure into unstructured data. So if you already have structured data, such as Excel sheets, that can be pretty easy. You can do that with rule-based systems pretty easily. Just calculate something or create whatever out of it. But if you have unstructured data, that's where it often gets difficult in a data scientistic point of view. And then you can try to process that at scale with natural language processing, OCR, and gain all kinds of insights. For example, law firms are using it now a lot to, of course, look at potential pain points, contracts, run the contracts. Those might be, 10,000 contracts that are all almost identical, but only almost. Run them through an LM and tell them, tell me the differences and what are the compliance pain points now that we have this new judgment from our high court what exactly is it that I need to adapt? The interesting thing is, what do you think about, what are people saying? Is this a useful application so far for, I don't have numbers for that, but I have quite a bit of anecdotal insight. Would you say most people in law firms say this is a great application or this is not a great application? Raise your hand if you think this is a great application. Not too many lawyers around him. Okay. Well, if raise your hand if you don't think it's a great application. A lot of extensions as usual. So actually, what I'm seeing is there was a lot of hype around this early on. Now people actually field testing it, and it turns out it's oftentimes not a great application. Why? On the one hand, of course, you get all kinds of flags, and you can cluster these 10,000 contracts. But at the same time, the problem is we've already seen there's hallucinations, there's unreliability. So what the associates then actually do is they play around with the LLM for half an hour, and then they still go back to the work that they usually would have to do. They were prompted by the LLM to look at specific parts of the contract, but they cannot be really sure that the LLM has no looked at. So actually, you have to see whether the speed up through the LLM is actually greater than the amount of time you spend with the LLM and analyze the output of the LLM. And it turns out, in many cases, it's not. So because persona approach, you actually have to look at it exactly again. So once the confidence level of LLMs and AI gets even greater, and you can be confident to say, okay, I get this out of the engine, and I'm pretty sure it's really correct. I might prove upon it. That, of course, is great. You're saving yourselves, maybe 100 hours doing this in half an hour. But as long as you still have to manually verify everything, which at the moment is something you really have to do, particularly for high stakes decisions, then it becomes really a non-starter. So that's why we have potential efficiency here that we can introduce, particularly I'd say for non-high stakes decisions or for things where we can be pretty sure that the LLM or the AI is really correct and accurate. And for that, you really want to look at some of the statistics, at some of the precision value, at some of the accuracy values. But it can also go the other way. So hallucinations, garbage in, garbage out, still needs human oversight. And again, you kind of need to make the calculation whether that oversight doesn't mean that you're actually adding hours plus cost to what you're doing or not. And it's only one way to find out, and you just have to try, but that's why you're piloting things and you don't roll them out big time all at once. At least that's what I would recommend. Okay. One thing where AI is really improving things from what I hear from friends of mine who are precisely in this business is fraud detection. I mean, they're not in the fraud business, they're in the fraud detection business. Should say, well, different friends actually in different role here. So of course, anomaly detection is a classic thing of data analytics. And you can now introduce this into banking, KYC gets automated, and there you do have massive speed up. Again, of course, it's a matter of balancing false positives and false negatives. You don't want the model to, be on alert all the time so that customers such as myself can withdraw money only because they're in a different country. I don't know how many times my credit card has been blocked and it's left stranded there, or, begging friends to, chip me over a dime or something because I really cannot do anything in this country. I brought zero, of course, zero cash on there. Plus, on the other hand, waiting too much through. So that's something that, again, data scientists have to figure out. But this is, I think, really good application. We will see that the AI Act actually privileges this to some extent. Another thing I've already talked about a little bit in the law firm case, so classifying documents. Interesting thing is that oftentimes you will have a pipeline, again, of different technologies. So you have OCR, then you do NLP or LLA, understanding some of the contents, and then you do, for example, this is K-nearest neighbors. This is a classical, traditional, unsupervised AI strategy or technique for clustering things to compare how close they are to one another. So again, it's not generative guys doing all the magic. Rather, it can be one element in a pipeline of more established tools, and just have to see if that one element actually brings enough value for you to buy that additional component. Again, you can do all kinds of things, compliance tracking. You can speed up retrievals, of course, but again, you need to check for the risk of misclassification and then establish some kind of oversight board. On the one hand, you need technical oversight, and on the other hand, you need, of course, compliance oversight, because these new technologies do bring in new regulatory challenges. So broadly speaking, I've seen cases online then, and also talking to people where you do have a reduction in document handling times. Again, you need to check always if that includes double checking on the result, or if that is just, the baseline without the double checking. You can, of course, in some cases bring down the error rates, but I think bring down error rates oftentimes is something that needs traditional non-generative AI or even rule-based systems. For generative AI, it's not necessarily the case that you bring down error rates. And then you need to double check whether that actually produces grad 2 in ROI. So those are some of the things that can happen, of course. The AI could wrongly label or understand the red setter and really not truly cabinet. It can create these hallucinations. There was a really interesting study that just came out on pruning. Why is it really interesting? Because if there's one domain where people, AI experts, agree that AI is really good at, that's coding. Okay, a lot of the young coders use AI even excessively, to the extent that they don't really learn how to code anymore, as some computer science professors tell me. Anyways, so this is one of the areas where Gen AI is supposed to make a difference. And now we have perhaps the first really well done randomized controlled study. So this is the gold standard in academia, right? By Measure, which is a really good research firm, on coding. And so they gave coders the option to use Gen AI and others not the option. And it turns out that those who used Gen AI actually took more time to complete their tasks, which is a bit surprising, surprised them too. And why is that the case? What do you think? Why did they take longer when they used AI, Gen AI? Because of the prompting, okay? They might have taken a bit of time to do the prompting to actually get the right answer. Yeah. Time to review. Yeah, precisely. So that's the main driver, time to review. Because in coding, again, it's oftentimes hard to spot if there is, one parenthesis, one comma, whatever missing. But if that's missing, screws up the whole thing, right? So you get a piece of code really quick and it looks really great. And maybe it works in 75 to 80 to 90% of the cases, but you still have to review it because it might not work. And that just added that time. And those are professionals. Those were coding professionals and added time. So again, if you do that, it might be that you're adding time and cost. So I'm not saying don't use AI. I'm a big fan of AI, actually, in many instances, but you just do the checks. Test it internally and see if it works or not. Do you believe there will be a time where we really can trust AI? Where we can trust AI, yes. I think a day, yes. That I don't know. In how many years? If I knew that, I wouldn't be here. I would be on the Bahamas, But the point is, I think we do see that increasingly models are designed to reduce hallucinations, instability, etc. So this is industry knows, so in terms of the developing companies know that this is the biggest problem for uptake in companies. And so they're putting a lot of money into efforts to do that. Now with the current transformer-based architecture, transformers are those with attention mechanism, that's really hard to do to actually get that down to zero. So I think the idea will be either to combine it in smart ways with rule-based systems to still get the advantage of the LLM looking for a lot of data, but then having a good rule-based system that kind of tries to sort out that false positives. Plus, looking at new architectures. And this is something that research is currently doing at a fast pace, but obviously with all kinds of breakthroughs that you need. Nobody knows if this is coming in half a year, 10 years. And until then, I think this problem will continue to haunt us. And at the end of the day, we hope that AI will be similar to conventional software in terms of error rates, which of course has error rates, like humans had error rates. But as long as, you have a certain...
It's another point, because it's the real question. You're comparing AI to software, you have to compare AI to human.
Yeah, I mean, to be alternative task formulation that would be done. And that's up. Sorry?
Sources, yes.
But shit.
I think we will very soon see a time where more likely to prompt AI than to prompt.
Yeah. In many instances, I trust AI more than humans. It really depends on the task, right? But again, if it's a task that humans have to do, the question is, does the AI time come on top of the human time, or does it reduce the human time because it already points you, flags a number of things? You can be fairly confident the flags are at least almost always accurate, right? Yeah.
Is there any evidence that if we start using AI, we think differently, particularly more shallowly about the problem?
About the problem? Yes, there are that we could think more shallowly. Okay, so question is how to conceptualize that. But I know of empirical studies that first suggest that when students, for example, use AI to deal with exercises, and you put students in 3 groups, you have first group, no access to modern technology. Second group, you can Google. Third group, you can use Gen AI. The group that does best is the Google group, not on a completion, but on whatever, 1 day later, doing a test on it. Because if you still old school Google it, then you have to still think about something and write it up. Whilst the Gen AI people, they just copy paste it, but by copy pasting, you're just not learning anything. So that's one thing. Of course, you can use Gen AI for AI. I use a lot with my students, but I tell them, don't just copy paste. You're gonna And so that's one thing. And thinking more shallowly about things, there isn't a lot of anecdotal evidence. I don't know specifically of a study, but there's a big Nielsen G study that showed that people fall asleep behind the wheel. So even professional consultants, ECG consultants who over-relied on AI and used it then for cases where it's actually not well suited to handle that case. Those were more analytical spreadsheet cases versus more creative cases. So that case where Gen AI was actually boosting productivity, that was design a new shoe and then market for a new shoe that was, I don't know, something weird to come up with. So that is actually very good. But then there was spreadsheet cases where, you had to find basically one error in the data compared to interviews, etc. And that it failed. And here's the people with AI actually failed quite miserable. So yes. We're how many more minutes? 10 more minutes. Oh, that's great. I'm almost at the end. Where's my clicker? Okay, here. So, human oversight remains essential. Addressing bias is essential. If you want to learn more about with the paper that I just recently wrote about discrimination in Gen AI, so that's also an interesting element. Let me just, before we finish, say something about a regulatory focus. I don't want to go into detail. If you want to know more about this, come join us at one of our other events where we talk about this in greater depth. But basically, you might have heard about the AI Act, which is the big horizontal legislative instrument in the EU. It has 4 different risk levels: prohibited, Schengen-style social scoring; high risk, limited risk, basically chatbots; and then minimal risk, where you don't have to do much. It's for internal logistics, etc. You don't have to do much in your company. You just have to make sure that everyone on staff that deals with AI has AI literacy. And then ChatGPT arrived, and the 5th layer was added, and I was actually quite involved in this, a layer specifically for general purpose AI models. So those are all systems, and this is for general purpose AI models. Think Gen AI models, think GPT-5, etc. So here we had to define AI, because now it's the AI Act. It's a law. about AI is it needs to have an AI definition. And so here's the definition. It's a machine-based system with varying degrees of autonomy. That's a great definition of varying, somewhere between 0 and 10. That infers from input it receives how to generate outputs that can influence the physical or virtual environment. That's also great, influencing physical or virtual environments. Tell me one piece of software that does not influence a physical or virtual environment, right? Also, tell me about one piece of software that does not use input to generate output. Right. So all of the burden is on inference, which is, it's a weird definition. It was ordered from the OECD. The OECD came up with this total nonsense, actually definition of software, I think. But it doesn't matter. It just means that it's a very broad definition of AI. So most of the things that you're using, and you might not even think it's AI, like good old school, logistic regression, etc., it might actually be AI. So it's machine learning, very broadly understood. And now what you need to know, basically, is there are two main roles in the AI Act. One is the providers, and the other one is the employers. Providers, those are the guys or the entities and the ladies, of course, who develop or have developed an AI system or a GPI, general purpose AI model, and they put it on the market or into service under their own name or trademark. So basically, note that even if you don't develop something yourself, but you have a different company and you tell them, look, can you build this tool for me? And then you take that and you put your name, your brand on it and say, hey, this is my Adobe GPT, who are the sponsors? I can't remember. My Proxid, whatever. GPT, this will be you, the provider, even though you did not write a single line of code and did not do one piece of testing. Okay, so it's basically you assuming responsibility. You get this coolness of branding it, but you paper it with legal exposure. So that's one thing you need to know. If you just want to be a deployer, then you just assist the entity who uses the AI system. You don't develop it, you don't have it developed, and you don't put your name or trademark on it. And why is that important? Because GPIs, the GPI models, general purpose AI models, all of the providers, those are all rules for providers, they have to have enough transparency and copyright disclosures. That's one thing you can rather easily handle. Copyright can be tricky, as we know, 1.5 billion settlement to Anthropic. But importantly, if it's a really big model called with systemic risk, then you need to do a bunch of other things, risk management, red teaming, incident reporting, that you don't want to do if you're not a professional AI development company. Okay? So that's because that's the kind of stuff that even OpenAI finds a little bit tricky. So my conclusion would be, what about fine-tuning? That's what a lot of people do. And here the EU Commission has just unveiled some reassuring guidance saying, as long as you don't use a lot of compute for fine-tuning, more specifically, if you use less than 1/3 of the compute that was used for the training of the original model, then you won't be considered, most likely, a provider. There is a presumption that you won't be a provider, but rather only the deployer of the model. So that's one takeaway. I'm going to skip over this in the interest of time. High-risk AI systems, just telling you again, this is this privilege that I've already talked about. There's a number of categories. For example, in employment, use AI employment. Then it becomes a high-risk AI system with all kinds of duties attached to it. But you use it in credit scoring and life and health insurance prediction. Yes, again, high-risk system, except you use it only for fraud regulation. But this is where the commission or the EU legislator said, hey, this makes sense. So we can accept that. Note that Gen AI is not a high-risk system. It has this blue specific level of regulation, the GPI rules, which are different from the high-risk rules. So one thing you would want to avoid as a takeaway is falling under the high-risk rules without knowing it. So your compliance team needs to know about that list. And also, you don't want to be a provider of a GPI model without knowing it. So if you do fine-tuning of more than 1/3 of the flops that were originally used, that's when you can get into trouble. And if you brand the model and say, hey, this is now my company GPT, again, that can put you into trouble if you use this like this in the EU. I have, maybe that's the last thing that would be of interest for the community here. So let me take 1 minute to do that. You need to disclose deepfakes. What are deepfakes? think of deepfakes. Example of deepfakes: the Pope and the Balenciaga stuff, right? Most people, when they think of deepfakes, is actually people, but it's an AI-generated or manipulated image video content that resembles existing persons, objects, places, entities, or events. So it could be basically anything that looks authentic but isn't authentic. So just for you to keep in mind, anything that tampers with documents and stuff, that can be a deepfake, and then you would have to say on the AI modified document, this was generated or modified by AI. Okay, if it looks authentic but it's not authentic, then you need to flag back out. For text, you don't need to do this. And one thing that helps with fraud detection is the last image. And my last query to you, I'm going to finish with this, is labeling. AI images or AI models need to have the capability built in to label stuff. So this is an image from beautiful Switzerland. It's all AI generated. This cow in front of the Matterhorn. And now you tell me, which part of it is labeled with a watermark? Is it the left-hand side or the right-hand side? It's kind of maybe a little difficult to see from behind, but what would you say? Left-hand side or right-hand side? Look closely. It's kind of hard to spot. No extension this time, okay? So who thinks it's the left-hand side? That's the headed cow that's labeled with watermark. No abstentions. All right, who thinks it's the right-hand side? It's everybody else. All right, so the answer is it's the left-hand side. The trick is you could not see it. I'm sorry, because I just want to point out to you that the labeling actually these days, it's not something like this huge stamp where you say, hey, my grandmother can take this out with Photoshop, but actually it's a very sophisticated kind of signature that's built into the pixels, like in electronic signatures, that you can read with the ciphering algorithm, so that if you're an interested NGO or any person that uses this algorithm, then you can know this was doctored or this was AI generated or not. But it's pretty easy, it's pretty hard to tamper with and to take this out as a third point. So with this, I'm going to leave you just with the compliance insights. Have a governance ethics council, classify the tools. Do I have GPI tools? Do I have high-risk tools? If you do, then do some documentation and use some transparency tools and bring in human in the loops and do audits, internal audits, to know whether actually the stuff that you're introducing is generating ROI or not. With this, I think the future will be exciting one way or another. Many thanks for your attention, and if you still have any questions, 1 or 2 minutes, I'm happy to take them. Thank you. I don't know, do we have time for 1 or 2 questions, or?
Yes, we do.
We do? That's great. There's a question, the red setter gentleman.
On the round slide, was it deliberate having the bean with the wrong value?
Where? On the what?
On the travel slide, with the travel files.
Yes, of course. It was AI generated, so it was for you to spot that this was actually an AI generated image. Thank you. Yes. Other questions?
I was interested earlier when you spoke about. I was interested earlier where we spoke about the extra-daily contribution for experienced developer using AI. I was very interested in the study if they consider the human factor. Because if I am an experienced developer, I'm educated to deny the help that AI can provide, because it's questioned by a bit to deliver.
Yeah.
So I was just curious if that security factor was talking to that there is.
So in that study, I don't think so. But there are other studies that show precisely that particularly the experts who have a great degree of expertise, or people who have considered themselves experts, they find the kind of work that they're doing oftentimes devalued by using Gen AI. Basically, I'm transitioning from a person who's straight up, to a person who's just copy pasting and checking and doing riffing, kind of the stuff that I hired people to do, and I have to do this myself. So yes, that can actually be an issue, particularly with workforce morale. one of the big things, takeaways, I have colleagues and friends who work very high level in the commission or work with the commission on a lot of the employment rules. And they always tell me it's not about preserving the quantity of jobs, it's about preserving the quality of jobs. Because AI won't take away all sorts of jobs all of a sudden, but it may take away a significant degree of quality if you don't do it right. And that, of course, can really hurt your company if some of your top people start feeling, a little bit lulled and bored and stuff. So yes, that is a real concern. And again, it's one of the things that you have to test for and check for when you introduce AI.
I think we thank you, Philip, again.
Thank you so much.